questions that I find most interesting to pursue in research generally have arisen from patients that I've seen either on the ward or in my clinic, and it's really satisfying to be able to take the problems that I see every day in clinical practice into the lab to try to find solutions. CAR T-cell therapy has been incredibly effective and has provided the opportunity for cure to significant proportions of patients who didn't have other treatment options. But about half of patients in even the most successfully treated blood cancers still ultimately don't respond or relapse after CAR T-cell therapy. And what I'm particularly interested in is those patients who have a very, very good response where we can't find the cancer at all, even when we look at very sensitive technologies, and yet months or years later the cancer returns. And so I'm interested in trying to understand what those very, very rare cancer cells that are able to persist in the body following and during CAR T-cell therapy, how they're able to stay there despite such strong effective pressure and ultimately see relapse. Within the lab here at Peter Mac, we've developed a number of really interesting technologies that allow us to trace the origin and the fate of individual leukemia cells. We can see what they were like before treatment, we can study what they were like in the midst of treatment, and we can understand what they are like when they come back after treatment. And understanding this sort of life cycle of individual cells and the cells that arise from them allow us to work out what the critical decisions that these cancer cells are making when they first encounter treatment that allows them to adapt and persist and ultimately cause relapse. We mostly deliver CAR T-cell therapy for patients who have relapsed or not responded to our standard treatments. And so this is a really high unmet area of need where we don't have many proven and effective therapeutic options for patients who relapse after CAR T-cell therapy. So we can work out ways to reduce the number of patients relapsing, then we can have a really significant impact in hopefully curing a much larger proportion of patients that we treat at the moment.